Hello and welcome to my channel. My name is Nabil and today's topic is ABI encoding specification. In today's video we are going to learn about function selector and argument encoding. In other words, what happens under the hood when we call a function in a contract at byte level. After watching this video, we are going to learn how things are working at byte level and more importantly how to construct and manipulate Calldata at byte level. So if you are interested, let's get started. The first thing is we need to understand the basic design of ABI specification, and to do that we can look into the Solidity documentation. Here we can see that the contract application binary interface, which is ABI, is the standard way to interact with contracts in the Ethereum ecosystem. To understand a little bit deeper what this ABI is, the blueprint of your contract, of any contract that's on the Ethereum blockchain. When a Web3 developer compiles a contract and push it onto the Ethereum network mainnet, it gets compiled. Solidity compiles it into bytecode, which the EVM will understand. It's the language of the EVM, Ethereum virtual machine. So it's mainly this blueprint is mainly used when there is an interaction between contract and a contract or a user with a contract. So the main question is, how am I going to, when I call a function, what happened? What's the thing that it's happening underneath? First, when we call a contract, we're going to see in this example here, I just took a simple contract from the internet. This simple contract has many functions like switch, turn switch on and turn switch off. For example, what happened when we call this function turn switch on? First, we acquire the address of this contract, and then we call this turn switch on. But what happens when we call this function? First, the EVM needs a function selector. What is a function selector? Is a 4-byte. That's a 4-byte identifier which is unique to every function within that contract. To understand it more, in Solidity, a function selector is a 4-byte identifier that uniquely represents a function in a smart contract, and it is derived from the CAC 256 hash of the function signature. What does that mean? Well, when we call, for example, when we call a switch on, what does the EVM takes is this string. Is that like this? This is the one that the EVM will take to select our function. For example, we're gonna change it to on. To understand more, we take the function as it is, and we hash it using this protocol, which was taken arbitrarily by Solidity. This hashing mechanism gives us a 256 bit, but we only take 4 bytes from it. It's the first 4 bytes. It's the left ones, the most significant 4 bytes of that 256 bit. It's mainly like this. It's 0x to mean we are in hexadecimal, and 4 bytes. The first byte, second, third, and fourth. This byte this 4 byte is unique for that function on that contract. And for example, if our function takes arguments like for example you int 256 a and a boolean value of b, we need to include included in this in our function selector. That's the first thing. It's crucial to know that the function selector is the first thing that we put in our Calldata. Then the argument encoding. This is what it gets a little bit twisted. Argument encoding. This is when you put the argument beside next to the function selector. How we do that is a little bit sketchy. For example, when we put the function selector, we take each slot of 32 bytes and we put the first argument. We go to the next 32 bytes and put the second argument, whether the argument is 32 or less. But you might ask the question: what if the argument is a data that which length is variable? Well, that's a very good question. That's when it gets tricky. How we do that is when the data comes, the term data comes, we instead of putting the data itself, which exceeds, let's say this is a string that exceeds 32 bytes. Instead of putting the value itself in that slot, you put a pointer, a cursor that tells the EVM, no, don't read this data, go to the slot number or go to the byte number X, and there I will the data. This is where the data exists. This is where you need to be very you need to pay attention when you construct your Calldata. To understand this more, I encourage you to do a small exercise. Here there is a function that's called bar that takes byte tree. That's an array that takes 2 byte tree elements. How are we gonna do that? The first thing is the function selector. The function selector is of bar byte 32, for example, is this string. We can type it right away. For example, we can say, please give us the byte 4 of kickack 256 of bar byte 3 of 2. This is the value, and then we're gonna put our 2 elements, our 2 data. For example, if I want to send ABC and DEF, this is the first slot, and this is the second, which first contain ABC and the third contain DEF, and they are right padded. Strings and bytes which lengths are variable are right padded, and uint and addresses and all other value and bools are left padded. But there is something important that we should take in consideration, is that the slots start counting from the first argument. Like this is the byte 00. So 61 is the byte 00. 62 is the byte number 1. 63 is the byte number 3, and so on. If we go to this, it's the byte number 32. Sorry, 32. This 64 is byte number 64. It doesn't start from the function selector. It does start from the argument itself. This is crucial because we're gonna do an exercise afterwards to test our understanding. So this is the first example gone. Let's take the second. The second is the same thing, because uint, we know the length of our argument, and bool, we know also the length of our argument. It's the same thing. We're gonna put x on this value, on this slot, but uint, we're gonna start from here. If, for example, x equal 1, we're gonna put 1 here. all other values are 0. And for bool, whether it's 1 or 2 or 1 or 0, we're gonna put either 1 or 0 here. So the second, and also we need to change the function selector according to buzz, not bar. Okay, let's do the third example, which is here we have bytes. Bytes have a string which length is variable. What we're gonna do? So I'm gonna delete this. I'm gonna take this example. Where is it? Okay, so if you want to call sum with argument Dave and true and 1, 2, 3, Dave is our byte, bool is our true, which is equal to 1, and uint memory, which is an array with unknown variables, unknown number of elements. I'm gonna send 1, 2, and 3. So the first thing is always the function selector, which is byte of kcalc 256 of Sam, byte bool, and uint 256. We always put the type of our argument inside the function, which gives us always 4 bytes. This is function selector. When the EVM sees this function selector, he knows for sure he will go to Sam and execute this function. So the last time we said for bytes, we don't put the value itself, we put the pointer. In this example, our first argument is byte, but the pointer tells us the location of the data part of this parameter, which is dynamic, measured in byte from the start of our argument block. It's in this case in the byte number 60 in hexadecimal, which is 96, or I'm not for sure, but it's in decimals is 96. This data tells me that the data is not in this slot, but in slot number, in the byte number 60. We do nothing for now. The next slot, which is I'm gonna put it here, 0, 0. This is the byte 0, 0, 1, and this is 31, and this is 32. Okay, from beginning of the slot 32, we're gonna put our value bool, which is true. We're gonna put 1 here. The second parameter, boolean true. The third value, which is of memory uint, we always, for arguments, we either put the value itself or put the pointer, because the EVM follows always the order of the arguments. First, for the memory, we put the pointer. Second, for the bool, which know the length, we put the value itself. And third, for the uint, an array with unknown length, we're gonna also put a pointer. This is the byte number 64. So in this slot, or in this 32 byte slot, we put the location, another location, which in this case, in hexadecimal, I0. It's all gonna fall in place when we finish this example. So this is the byte 96, which I believe. This is the byte 60 in hexadecimal, which is 96. Here we're gonna put our first byte memory, the first argument. But before putting the data itself, we tell the EVM the length of this byte. We always have to tell the EVM the length of our data. In this case, it's Dave, so it's 4 characters, D, N, A, V, and E. We put 4. The data part of this argument, it starts with length of byte array in this element. In this case, it's 4. We put 4. And the EVM knows that he's gonna take the first 4 bytes of the next slot. You see? This is where he takes the first 4 bytes. 64, 61, 76, and 65. And for example, 64 is the ASCII value of D, and so on for 61 for A, and E for 65. If we put a lot of value, in case of Dave, we put a sentence, we need to count how many characters on it. And if it exceeds the slot, we're gonna take, if the value exceeds this slot, we're gonna go to the other slot. The EVM won't stop until he takes the whole data. But in this case, the data length is only 4, so we're gonna only take the first 4 bytes. Okay, and the second one, we're gonna. This is the slot number 696. This is 128. I think this is 128. I believe, if I'm not mistaken. Which is I0 in hexadecimal. In this slot, we're gonna put the same thing because we have array and we don't know how many elements of it. In this case, we send 1.3, so there is 3 variables, 3 elements. We're gonna put 3, and EVM knows that he's gonna take 3 elements, but our array in this case is a uint256, so he knows he will take 3 slots of uint, 3 slots of 256 bits, which is 32 bytes, which is the right length of our slot. The first he takes 1, which is here. The second slot takes 2, okay, and third slot is 3. And like that, we constructed our Calldata. If we send this data like this, and preceded by the address of our contract, we're gonna execute SAM. But okay, but we don't know what SAM does, so it depends on what contract you are communicating on it. So I hope you understood this example. If you understood this function SAM, I think you can understand in every function whether it contains a variable with unknown length and with a variable with known types. So to conclude, I'm gonna make this exercise. We're gonna take this exercise. Shall we go to the right place? It will not switch. No, it's switch. I'm gonna put the link in the description. And if you can, with my explanation, I think you can pass this exercise. The exercise tell us to just have to flip the switch. Can't be that hard, right? So I encourage you to take this exercise. It's a really challenging exercise, but it will cast your understanding about Calldata. So I hope you enjoyed this session, and I hope you understood how to construct Calldata and how function selector and argument encoding works. If you have any questions or improvement, or let's say other topics you would like me to cover in the future, please comment below. I'm really open to those discussions. I enjoy sharing my knowledge with other people, so people can increase their skills and become Web3 developers or auditors. So see you next time.